In this video, I wanted to get just a little bit deeper into linear equations and also show some of the more nonlinear types of functions so that you can see kind of what they look like. Let's go back to the previous example where we talked about 2 points. One of them was 2, 8, and we're going to call that point A for now. And the other one was -1 and 6, and we'll call that point B. Notice that our coordinates go from down here around -2 all the way up to just a little more than 9. Back here a little more than -11 all the way up to also just a little bit more than a -11. This, of course, is the x-axis, and this now we're going to call the y-axis. So here we're on the y-axis. And we had an equation, and this time we'll call the equation 5y minus 3x, but we normally, in the appropriate form, list the x first. So we'll call this a -3x plus 5y, and that's equal to 34. So that's the same equation that we looked at last time, and remember, as we predicted, 2, 8 would fall on that line because 2, 8 is the solution to 3x plus 5y equals 34. However, -1, 6 doesn't fall on that line because that is not a solution to this equation here. So, as you can see, when I have an equation where my x has a exponent of 1, I have a linear equation. The solution is a line, and it goes off infinitely in a positive direction and in a negative direction. Also note that it points towards quadrants 1 and down to 3, right? Because it's a positive slope, and we'll talk about what slope means later. If it were a negative slope, it would point in the opposite direction towards quadrants 2 and 4. So this is a linear equation, and let's contrast that with an equation that has a square in it. So if I had x squared minus 2, then I've got a different sort of shape, don't I? This function here is called a parabola. It's got a minimum value and no maximum value. It'll go on up and up forever and ever, slowly opening out. This is one of our conic sections that we will learn a lot about going forward, but for now, what's important to note is that when we have an x squared, by contrast to having a not x squared, that our function, our graph, looks a little bit different. Let's take a look at a function. So we've got one that's got x, and now we've got one that's got an x squared. Let's try one that has an x to the third power. And look and see how even that is different. Let's color coordinate these a little bit. Let's put our x in red. Let's put our x squared in blue. Let's put our x to the third power in green, and look at the difference between the way these three graphs behave. Notice that my x to the first power goes off in that direction, up infinitely, and down infinitely. It goes in almost inverse directions, right? It goes up this way and down this way. Versus my x squared, which goes from a vertex, from a lowest point, it goes up infinitely on one side, and it goes up infinitely on the other side. Well, that's pretty interesting. And take a look now at how my x to the third power, let's turn off the grid here so you can see a little bit better. But let's see how the x to the third power, much like my line, points in opposite directions. See, there's kind of an inflection point where the curve changes and then the curve changes again. But in the negative direction, it goes down. In the positive direction, x direction, it goes up. See how that's different from how in the negative direction on my x squared it goes up? And in the positive direction, my x squared also goes up. So based on those differences, let's see if you can predict which way an x to the fourth power would go. Well, if you guessed up in both directions. And let's spread this out a little bit because it's getting hard to see. Let's see. There we go. So this black one here is my x to the fourth. And notice that after a little wonkiness down here, after a couple of inflection points, it also is going up in both directions, in the negative x direction and the positive x direction. My x squared is going up in the negative x direction and the positive x direction. Whereas my x to the first power, my line, which is what we're going to be studying the rest of the module, is going down in the negative direction and up in the positive direction. And my x to the third power also, after a couple inflection points, goes down in the negative direction and up in the positive direction. See if you can tell me why that is. Hazard a guess. Write down the answer to why you think that is. Why do these two go up, whereas these two go up and down? And bring that answer to class. We will discuss it in class.